You know, whenever you see a picture of a satellite or maybe a lunar lander, have you ever wondered about that shiny, crinkly gold stuff all over it? It kind of looks like someone wrapped it in the most expensive kitchen foil ever, right? Well, today, we're going to unpack that mystery.
All right, let's get right into it. Why do they do that? The answer is, well, it's actually way cooler and more complex than you probably think. And it really gets to the core of what it takes to survive out there in one of the most brutal environments we can imagine.
So, let's start with a big reveal. The first thing you absolutely need to know about all that gold foil is that it's not actually gold. And it's not really foil either.
Yeah, you heard me right. What you're actually looking at is this super high-tech thermal blanket called multi-layer insulation, or MLI for short. And its purpose? It has nothing to do with looking fancy. It is all about pure, critical function.
The best way to think about MLI is like a space-age thermos, but for a multi-million-dollar satellite. Its one and only job is to keep all the super-sensitive electronics inside at a nice, stable temperature. Doesn't matter if it's getting blasted by the sun or freezing in the dark.
So how does this magic blanket even work? Well, it's made up of dozens of layers of super thin plastic, stuff like Kapton or Mylar. And each of those layers is coated with a crazy thin film of aluminum. Now here's the secret. The plastic itself, the Kapton, has this natural amber color. That's what gives it that classic golden look. These layers are amazing. They bounce solar radiation away to keep things cool, but they also trap the heat that the electronics inside generate, stopping them from turning into popsicles when the spacecraft flies into a shadow.
All right, so myth busted. It's not gold foil. But that just leads to an even better question, right? Is there any real gold up there in space? And the answer is a huge yes. And believe me, the way it's actually used is way more mind-blowing than just fancy wrapping. So, first up, we've got to talk about one of gold's most spectacular jobs, acting as a perfect mirror. A mirror that lets us look all the way back to the beginning of time. What you're looking at here, that's the main mirror of the James Webb Space Telescope. And yep, those incredible hexagonal segments are coated in a super thin layer of pure 24-karat gold. It was vapor deposited right onto the surface. And when I say thin, I mean it's about 1,000 times thinner than a human hair, but its job is just massive. So, why gold, of all things? Well, the James Webb Telescope is designed to see the universe in infrared light. You see, the light from the very first galaxies, the most ancient ones, has been traveling for billions of years. And over that time, its wavelength has been stretched out all the way into the infrared part of the spectrum. And wouldn't you know it, gold just happens to be one of the best materials on the planet for reflecting infrared light.
Just how good are we talking? Get this. There's a special coating process, and they call it, get this, laser gold. It can reflect an insane 99.4% of near-infrared light. That kind of efficiency is exactly what lets the telescope capture that super faint, ancient light with the stunning clarity we see in those images. And this is what it's all for. Every single breathtaking image we get from the JWST, whether it's a glowing nebula or one of those first galaxies, it's all possible because of that microscopically thin, perfectly reflective layer of gold. It is literally helping us see our own cosmic origins.
Okay, so from peering into the distant past, let's bring it a little closer to home, or at least closer to the humans traveling out there. Gold plays another absolutely critical role here, this time as a shield for astronauts.
See, down here on Earth, our atmosphere does us a huge favor by filtering out the sun's worst radiation. But out in the vacuum of space, there's nothing, no filter. As astronaut Koichi Wakata put it, in space, a trip to the beach can literally sear your eyeballs. And that's not an exaggeration.
So what's the solution? You guessed it, a micro-thin layer of pure gold. It's applied right onto the astronaut's helmet visor. It basically creates the most advanced, most important pair of sunglasses ever invented. This thin gold film is a total marvel of engineering. It reflects away all the dangerous infrared and UV radiation. It cuts down that blinding glare. But, and this is the key part, it stays perfectly transparent so the astronaut can see clearly. It is the ultimate protection for the human eye against the raw, unfiltered power of our sun.
All right, let's talk about gold's last big job in space. It's maybe the least glamorous, you don't really see it, but it is absolutely essential. It's all about reliability. It's the secret ingredient that makes sure everything from tiny circuits to big moving parts works perfectly, not just for a day, but for decades.
Think about it. In the harshness of space, you just can't afford a single connection to fail. Now, sure, other metals like silver or copper are slightly better conductors, but they have a fatal flaw. They tarnish, they corrode. Gold, on the other hand, is chemically inert. It doesn't rust, it doesn't oxidize. That means a connection made with gold today will be just as perfect 30 years from now, protecting a multi-billion-dollar mission. So gold is really a triple threat up there. Of course, it's used in circuits and connectors because it conducts flawlessly and never corrodes. But here's the really wild part. It's also used as a lubricant. See, in a vacuum, normal liquid lubricants would just boil off into space. Gold, however, can be applied as a dry film. Its molecules slide past each other super easily, which keeps critical moving parts from just seizing up solid.
So it's pretty clear that gold is an absolute superstar material for space exploration. But as you can probably guess, all that amazing performance, it comes with a couple of pretty big trade-offs. So when you lay it all out, gold's properties are almost tailor-made for space. Its ability to reflect, to conduct, and to resist corrosion, those are just non-negotiables for mission success. The real challenge for engineers is this constant balancing act. They have to weigh all these incredible benefits against the two big downsides, the super high cost and the heavy weight of launching every single gram of it off this planet. And that kind of leaves us with a final thought to chew on. Down here on Earth, we think of gold's value in, dollars and cents. But up there, in space, its value is measured in scientific discoveries, in successful missions, in astronaut lives that are protected. It really makes you rethink, what's the true value of anything, really?